In this next video, we're going to take a look at the area of triangles. First, we need to know what triangles are. Triangles are considered three-sided, closed figures which have no curved lines. Now we're going to take a look at some examples and non-examples of triangles. Our first triangle here, or our first example here, is clearly a triangle. It has three sides, it's closed, and it has no curved lines. In our first non-example here, we have three sides, however, it's not a closed figure. Our second non-example is shown here. It has two straight lines, but it has curved lines. Even though it's closed, we have a curved line there. And our final non-example of a triangle is this shown here. It has four full sides, it's closed, and it has no curved lines. So the key word there is that it has four sides. Our first type of triangle we're going to look at is called a right triangle. A right triangle has one 90-degree angle. Notice that we have our triangle in the picture here, and it is signified by that 90-degree angle at the bottom left corner. How can we find the area? Well, think about it this way. What happens if we copy that right triangle and duplicate it? As you can see, I just duplicated that right triangle. What happens if we rotate it? We finally have it rotated, and notice what happened there. Doesn't that look like a rectangle? We know how to find the area of a rectangle. Remember, area of a rectangle is just base times height. What's our base here? Our base is 3 inches because the base is just the side that your figure is sitting on. Now we'll multiply 3 inches by our height. We need to figure out what our height is. Our height is just 4 inches here. So we multiply 4 inches by 3 inches. Now we multiply 3 times 4. 3 times 4 gives us 12, and inches times inches gives us inches squared. So that's the area of that rectangle, which is twice that of the triangle. Our only problem is that we found the area of the rectangle. We want the area of the triangle. Well, isn't the area of the triangle just half that of the rectangle? Because I said I copied it, rotated it. As you can see, the formula for our triangle is going to be 1/2 base times height. So that'll give us the area of that triangle. So we just take 1/2 of 12 inches squared, and that gives us 6 inches squared. And that is the area of that right triangle. A second type of triangle is called an equilateral triangle. An equilateral triangle has all sides of equal length. Here is a type of equilateral triangle. Each side has 7 centimeters in length. What happens if we copy this triangle and duplicate it? Now we have the second equilateral triangle copied and duplicated. Now we're going to rotate it. Now we have our two triangles lined up. As you can see, this is just a parallelogram. We know how to calculate the area of a parallelogram. The area of a parallelogram is just base times height. Our base in this case is just 7 centimeters. What's our height in this case? In this case, the height is just that segment that connects your base at a 90-degree angle. Well, isn't that height just 6 centimeters? Now we just multiply the 7 by their 6, and we get 42. And then remember, centimeters times centimeters gives us centimeters squared. So the area of that parallelogram is 42 centimeters squared. The trick is, we want to find the area of our triangle. All we did to find the area of our parallelogram was we just duplicated our triangle. Well, don't we have to just take half of that parallelogram? Half of the area of the parallelogram to find the area of our triangle? So half of 42 centimeters squared is just 21 centimeters squared. 21 centimeters squared will give us the area of that equilateral triangle. Now we'll take a look at a third type of triangle, which is called an isosceles triangle. An isosceles triangle has two sides of equal length. Here's an example of an isosceles triangle. Two sides are of equal length. Notice that 8 centimeters is equal to 8 centimeters, so that fits that description. Again, we're going to copy that isosceles triangle and duplicate it. After this triangle was duplicated, we're going to rotate it as follows. We're going to line it up. Finally, we have it rotated and lined up properly. This is just a parallelogram again. We know how to calculate the area of a parallelogram. Again, it's base times height. Our base in this case is going to be 5 centimeters in length, and our height is going to be 7 centimeters in length. So we multiply 5 centimeters by 7 centimeters, and that will give us 35 centimeters squared as the area of that parallelogram. However, we want to find the area of this triangle. The area of the triangle is just half that area of that parallelogram. To find the area of the triangle, we just take half of 35 centimeters squared. In other words, we take 35 centimeters squared and divide it by 2. And half of 35 centimeters squared is just 17.5 centimeters squared, which is the area of that triangle. A fourth type of triangle is called a scalene triangle. A scalene triangle has no sides of equal length. Here is an example of a scalene triangle. Again, we're going to copy that scalene triangle and duplicate it. Now we'll rotate that triangle as follows. We'll lay it on nicely. Once again, we have another parallelogram, so we'll need to find the area of this parallelogram. Area of a parallelogram is just base times height. Our base is 7 centimeters and our height is 2.5 centimeters. 7 centimeters times 2.5 centimeters will give us 17.5 centimeters squared. So now we'll take half of 17.5 centimeters squared to find the area of our triangle. Well, 17.5 times 1/2 is just 8.75 centimeters squared, and that's the area of that triangle. Another type of triangle is called an acute triangle. One property of an acute triangle is that all angles are less than 90 degrees. Here is the acute triangle example that we're looking at. As you can see, if you look at each corner of the triangle, we have one 45-degree angle, one 54-degree angle, and one 81-degree angle. Clearly, those are all less than 90 degrees. Once again, we'll copy this triangle and rotate it as follows. As you can see, we get another parallelogram. We'll calculate the area of this parallelogram, and again, area of a parallelogram is just base times height. Our base is 14 centimeters, and our height is just 10 centimeters. 14 centimeters times 10 centimeters is just 140 centimeters squared, and that's the area of that parallelogram. However, again, we need the area of just the triangle. The area of the triangle is just half the area of the parallelogram. So as we said before, we'll take half the area of our parallelogram in order to give us the area of the triangle. Half of 140 centimeters squared is just 70 centimeters squared, and 70 centimeters squared is the area of our triangle. A final type of triangle is called the obtuse triangle. An obtuse triangle is a triangle that has one angle greater than 90 degrees. So here's the obtuse triangle that we'll be looking at. Notice that in each corner we have one 30-degree angle, one 30-degree angle, and one 120-degree angle. Once again, we'll copy that triangle and rotate it as follows. If we know the area of a parallelogram is base times height, we know what our base is. Our base is 7 centimeters, and as you can see, our height is 2 centimeters. 7 centimeters times 2 centimeters gives us 14 centimeters squared, which represents the area of our parallelogram. To find the area of our triangle, we just take half the area of our parallelogram. And half 14 centimeters squared is just 7 centimeters squared. So 7 centimeters squared is the area of this triangle. As a concluding statement, notice that the area of any type of triangle is just 1/2 times base times height.